This is Geometry Section 7.6, parts of similar triangles. We do have a couple corollaries from Section 7.5 that we need to write down on your theorem sheet. So corollary 7.1 and 7.2, we've got to write those down on your theorem sheet before we move on. I went ahead and put them here. The first corollary is called the proportional parts of parallel, proportional parts of parallel lines. Of parallel lines. Proportional parts of parallel lines. And then the second one is congruent parts. So here's my symbol for congruent. Congruent parts of parallel lines. Okay. The first one is saying that if I have three lines that are parallel to each other and I have two transversals, let's say they're going like this, I can set up a proportion. So like if this is 2 and this is 3, then this is 4 and this is 6. I can set up a proportion between each of the segments here, these little tiny segments. Okay, so if three parallel lines, a proportion can be made for the segments. If you have three parallel lines, a proportion can be made for the segments. So 2 over 3 equals 4 over 6. 2 and 3, 4 and 6. Okay. The second one, corollary 7.2, says that if I have three parallel lines and I have two transversals and this guy is the same length as that one, those two segments are split exactly in half, then this one has to be split exactly in half. So this one is the same measure as that one. Kind of pretty basic. It should make sense that those, if these are split in half, those two should be split in half, but we just have to write it down. So if three parallel lines split a segment into two equal pieces, P-I-E-C-E-S, the other is split in two. Okay, if three parallel lines split a segment into two equal pieces, then the other segment is split into two equal pieces. Okay, that's what corollary 7.2 says. Okay, now we've got three theorems that are at the top of 7.6, so I'm going to go ahead and explain them here, and then I'll put them on your red sheet. So this one is saying that if, this one talks about altitudes of triangles, T-I-T-U-D-E-S, and altitude is this segment here. So if the point A was an airplane, the altitude is straight down perpendicular with the ground. If point F was an airplane, it's the altitude straight down perpendicular with the ground. So it's talking about the altitude. So if these triangles are similar, then this proportion, the proportion of the altitudes, has the same proportion as what the side lengths would. So like if this is 4 and this is 6 and that's 2, this would be 3. So they're going to have the same proportion. Okay, I'm going to write that on your sheet here. So theorem 7.8. I'm just going to do, what do we want to call this one? I'll call it altitudes. Altitudes. All right, so here are my two triangles, and here's my altitude. So I'll say this is 2, this is 3, this is 4, this is 6. Those are all the numbers that I always use. So I'll just say if triangles similar, altitudes are proportional. If these two triangles are similar, the altitudes have the same proportion as what the sides do. If triangles are similar, the altitudes are proportional. Okay. All right. The second one, 7.9, it's talking about an angle bisector. So each one of these segments bisects the angle, so you can kind of see that from the number of tick marks. Okay, if these two triangles are similar, then those angle bisectors will be proportional. So if this is 2 and this is 3, this is 4 and this is 6, it will have the same proportion as what the side lengths do. Now it doesn't necessarily have to be this side, it could be this bottom side, it could be this left side, we don't care, just as long as we're doing the angle bisector over the other angle bisector and one of the sides over one of the sides. So it doesn't matter which side, just like up here, the altitudes doesn't matter which just doesn't matter which side you're comparing the altitude to. It's just one of them. So this one is for theorem 7-9. It is for angle bisectors. So here is my triangle. Here's this smaller triangle. Here is my angle bisector, and this is another one. Okay, I'm going to say this is, should we use some different numbers? Let's say 5 and 3, and let's say this bottom side is 6 and this bottom side is 10. Okay, so 5 and 3, 6 and 10. All right, this is the angle bisector, and then I just compared it to the bottom side. So if triangles are similar, angle bisectors are proportional. Okay, 5 over 3 has the same proportion as 10 over 6, so we're good. All right, and the last one is 7-10. So theorem 7-10. If you need to pause this video, if I'm going too fast, please feel free to do so, because I am writing these rather fast. 7-10 has to do with the medians. Okay, a median, if you remember, is from the vertex to the midpoint. Vertex to midpoint, and it splits this exactly in 2 pieces. Vertex to midpoint splits it exactly in 2 pieces. Okay, now the medians, just like the altitudes and the angle bisectors, the medians will be the same proportion. So if this is 3 and this is 2, this guy will be 4 and this guy will be 6. So any of the sides will have the same proportion as what the medians will have, right? This is just talking about parts of similar triangles. Any of the parts, the altitudes, the angle bisectors, the medians, will have the same proportion as what any of the sides of the triangles have, right? So this one is for medians. All right, here is triangle, triangle. All right, I'm going to go my median this direction. So there's my midpoint. There's my median, midpoint, median. Let's say this one is, I don't know, I'm running out of ideas. 4 and 5 and 8 and 10. Okay, that median will have the same proportion. So 4 over 5 is the same proportion as 8 over 10. If triangles are similar, medians are proportional. If we have similar triangles, the medians are proportional. Okay. Oh, geez, we still have another one. We'll wait to do that one on the back until we get there. Okay, there's for medians. 4 over 5 equals 8 over 10. All of these parts will have the same proportion as what the sides do, right? Okay, example 1. So they have these triangles turned, but don't let that confuse you. This angle A corresponds to angle F. So this, these segments that are here in the middle, those are angle bisectors, and I can tell because it's bisecting the angle. Each one of these is split in half. Now it's not a median. A median would be if I had tick marks here and here and here and here. Okay, it's an angle bisector. It doesn't matter though. Median, angle bisector doesn't matter. The proportion will still be the same. So x is going to correspond to 8. So I can do x over 8 equals 15 over 12. There's going to have the same proportion. Okay, so equals 15 over 12, and then I just cross multiply. So 12x equals 8 times 15. 8 times 15 is 120. And then I divide by 12, so x is 10. Okay. Now, if you set your proportion up different than that, that's no problem. You could also do x over 15 equals 8 over 12, because regardless, just like I set it up here, when I cross multiply, I'm still going to end up taking 8 times 15, and I'm still going to end up taking x times 12. So if you set up your proportion different than somebody else does, you still may end up with the same answer. Okay, going to the back side. This is a story problem that I kind of like. Liliana is her name. She holds her arms straight out in front of her with her elbow straight and her thumb pointing up. I don't know if you guys have ever done this before, but you hold your finger like out in front of you like this, whoop, like this, and you look beyond your thumb to see, it's kind of like blurry behind it. You can do this test to figure out which eye is the dominant eye. Any of you guys who shoot trap have probably done this test before to figure out which eye you're going to shoot out of when you shoot trap. So closing one eye, she aligns one thumb with the car. So she's aligning her thumb with the car over here, and then when she closes that eye, the car jumps to over here. Okay. If you guys want to run this test on the clock or something, stick your thumb up to the clock in my room, and you can watch the clock jump when you blink one eye versus blinking the other eye. So the car jumps from one location to the other. Okay, the car jumps. The car length each car has a length of 5.5 feet, and it's jumping 4 car lengths. So the distance from here to here is 4 times 5.5, which is, I think, 22. Yeah, pretty sure it's 22. Okay, and then they have this length here is labeled as x. So the distance from her thumb to the cars is a length of x. That's what we're trying to find. Okay. Then it says if Liliana's arm is about 10 times longer than the distance between her eyes, this distance is 10 times longer than the distance between her eyes. Okay, so the distance between her eyes, we really don't know what that is. Maybe it's 4 inches, 3 inches, whatever. We just know that it's in the scale factor of 1 to 10. Okay, so if her if her eyes are 3 inches apart, this would be 30. But we're just going to reduce it down to 1 and 10. That's fine. Okay, so these two triangles are going to be similar to each other. So we can say that 1, which is this length here, corresponds to that 22, which is over here. And that's going to be equal to 10 over x. Okay, so 1 corresponds to 22, 10 corresponds to x. We're going to cross multiply. So 22 times 10 is 220 equals 1x, and I could divide the 1 over, or you don't have to. X is equal to 220, and the units are in feet. So 220 feet is how far her thumb is to the length of that car. Okay? All right. One more theorem, 711, is talking about the angle bisectors. Okay, and it says that this is a little bit different than the angle bisector that we had on the front side, okay? Because we're not talking about 2 triangles, we're just talking about 1 triangle, okay? So this one is saying that this length here, KM, whatever that proportion is to ML, so let's say that this is in the proportion of 2 to 3. Yeah, that'll work. This length here, KJ, will be in the same proportion as LJ. So let's say that that's 2, 3, and let's say this is 6 and 9. Okay? 6 and 9 has the same proportion as 2 and 3. So this bottom side and this side of the triangle will have the same proportion as this bottom side and this side of the triangle. Okay? All right, let's see if I can draw that on your theorem sheet here. This one is 711. Theorem 711. Triangle angle bisector. All right, and this one is saying, I have one triangle here. This is an angle bisector. If this is 2 and this is 3, this is 4 and this is 6. Okay, so I'm just going to say, given angle bisector, a proportion can be made with sides of 2 triangles that are created. Okay, so given the angle bisector, the 2 triangles that are created, I can make a proportion with their sides. Okay, so 2 over 3 and 4 over 6. All right? Given the angle bisector, a proportion can be made with the sides of those 2 triangles. All right, here's my question. So find x. All right, so here's my angle bisector. And the theorem that we just said stated that this guy here over this guy here has the same proportion as this one over this one. This guy over this guy. Okay, so this length right here is a length of x. And then we need to figure out what this length is. It's not 18. This length here is going to be less than 18. And if the whole length is 18 and this is the length of x, this length right here will be 18 minus x. It's whatever's left over, right? If this guy was 2, this guy would be 16. 18 minus 2 is 16. So 18 minus x is what that other side is. So x over 18 minus x will have the same proportion as 6 over 14. So 6 over 14, and then I do a little cross multiply and divide. So x times 14 is just going to give me 14x. Okay, that one's the easy part. And then this one's a little bit harder. So 18 times 6 is 108 minus 6x. Okay, make sure you distribute that for both of the pieces. So 108 minus 6x. And then we add 6x to both sides. So we get 20x over here, and we get 108 here. And if I divide by 20, x is going to be 5.8 divided by 20 is 4/10, so 5.4, I think. All right, perfect. There we go. Find x, that's all we needed to find. If we needed to find one of the other lengths, we would plug it back in. So make sure you're actually finding x and not another length. There you go.